Hello students, we are going to discuss about multi-component diffusion problems. Before discussing the problem of multi-component diffusion, we want to discuss what is multi-component diffusion. Symmetry of the fixed diffusion coefficient together with the overall simplicity of the fixed law in binary mixture, more than one component present in the mixture, create a wide range of possibilities for experimental measurement of the binary diffusion coefficient. In industrial application, diffusion transfer mainly occurs in mixture with more than two components, which significantly increases the number of unknown diffusion coefficient as well as the number of independent diffusion fluxes and forces. One thing is very important here, number of unknown diffusion coefficient is directly proportional to the number of independent diffusion fluxes and forces. So many independent diffusion fluxes are there and forces also there. In a mixture of n components, n minus 1 independent diffusion fluxes exist. The fixed law needs to be extended and generalized in order to take into account the interaction between fluxes and concentration gradient of different diffusing components. This is the multi-component diffusion correlation. Diffusivity of the component in a mixture of components can be calculated using the diffusivities for the various binary pair involved in the mixture. All of you know, define diffusivity. From fixed law of diffusion, diffusivity or diffusion coefficient is defined the ratio between rate of diffusion to concentration gradient. So this correlation made by Wilkie. Okay. So this is applicable for multi-component diffusion. D1 mixture is equal to 1 divided by y2 dash divided by d12 plus y3 dash divided by d13 plus etc. plus yn dash divided by d1n, where d1 mixture is the diffusivity for component 1 in the gas mixture. d1n is the diffusivity for the binary pair component 1 diffusing through component n. What is Y? Y is represent gases. But here we want to discuss only gas. We are not considering liquid. That's why we will consider small y represent gases. This is the mole fraction of gases. So here yn dash is the mole fraction of component n in the gas mixture evaluated on a component 1 free basis. So 1 free basis means we are not consider first component, we will consider only second, third and etc. Okay. So for y2 dash, formula is equal to y2 divided by y2 plus y3 plus etc. yn. So this is the problem of multi-component diffusion. Determine the diffusivity of carbon dioxide, oxygen and nitrogen in a gas mixture having the composition. So more than one component present in the problem. This problem obey the multi-component diffusion. Carbon dioxide 28.5%, oxygen 15%, nitrogen 56.5%. The gas mixture is at 273 Kelvin and 1.2 into 10 to the power of 5 Pascal. Binary diffusivity values are given as at 273 Kelvin D12P is equal to 1.874 meter square Pascal per second. Are you clear? So here diffusion of first component through second component. You multiply with the pressure. So diffusivity unit meter square per second. When this parameter multiply with the pressure, so we will get meter square Pascal per second. So D13P, what is the meaning of D13? The first component diffusing through third component. 1.945 meter square Pascal per second. So D23P, D23 means second component diffusing through third component. 1.834 meter square Pascal per second. Are you clear? So this is the problem. Percentages are given, total pressure is given, temperature is given, binary diffusivity value is also given. We want to calculate diffusivity of carbon dioxide, oxygen and nitrogen. Which one is the first component here? Carbon dioxide. Second component oxygen. Third component nitrogen. Are you clear now? Yes. So now we want to discuss solution part. Diffusivity of first component. Which one is the first component? Carbon dioxide. Carbon dioxide in mixture. So this is the diffusivity formula for multi-component diffusion. D1M is equal to 1 by Y2 dash divided by D12 plus Y3 dash divided by D13. For first component, so we will take Y2 dash and Y3 dash. So here Y2 dash is nothing but, so the component 1 free basis. So we will not consider first component, we will consider only second and third component. So here Y2 dash is equal to Y2 divided by Y2 plus Y3. So for this case, so all percentages are mole percentage. So that's why we will take mole fraction, individual mole divided by total mole. Which one is the individual mole? 28.5 kilomole. Are you clear? Percentage directly take in terms of kilomole. What about the total kilomole? 28.5 plus 15 plus 56.5, total is equal to 100 kilomole. For carbon dioxide mole fraction, 28.5 divided by 100. Oxygen mole fraction, 15 divided by 100. Nitrogen mole fraction, 56 divided by 100. Are you clear or not? Okay. So this is the mole fraction formula. Individual mole divided by total mole. For our case, Y2. Y2 is the oxygen mole fraction, second component. So 15 divided by 100, 0.15. Whole divided by Y2 is known, 0.15 plus which one is the Y3? Nitrogen. So nitrogen is the third component. 56.5 divided by 100, 0.565. So substitute all the value, find out Y2 dash 0.21. Similarly Y3 dash, Y3 divided by Y2 plus Y3. Why? Because Y1 is a free basis. So here Y3 also known. So individual mole divided by total mole. Similarly Y2 and Y3 substitute here. So find out the answer, Y3 dash 0.79. Are you clear or not? Okay. Yes. So the first point. So we have D1M value. Multiply with the pressure, that is equal to 1 divided by, so Y2 dash divided by that value, D12 plus Y3 dash divided by D13. So substitute all the value. D12 and D13 values are known, is right? So the substitute value, so find out the answer, D1M into P is equal to 1.93 meter square Pascal per second. Are you clear? So we want D1M only. Why? Because the question is the calculate diffusivity of carbon dioxide. We have D1M into P. So how will you find out D1M? So divided with the pressure, is right? So D1M P is equal to 1.93 meter square Pascal per second. So this value divided with pressure. Pressure already we have. This is the given data. 1.2 into 10 to the power of 5 Pascal. So divided with this value, finally we get D1m 1.61 into 10 to the power minus 5 meter square per second. Are you clear? This is the first part. Come to the second part. Diffusivity of second component, oxygen in the mixture. So what is the formula here? Second component, D2m is equal to 1 by y1 dash divided by D21 plus y3 dash divided by D23. Why? Because this case second component free basis. We will consider only first and third component. y1 dash is equal to y1 divided by y1 plus y3 is equal to 0.285 divided by 0.285 plus 0.565. Substitute the value. So the find out the answer 0.335. This is y1 dash. So why? Because this here we will not consider the second component. Why? Because second component free basis. Okay. So y3 dash similarly y3 divided by y1 plus y3. So all the values are known value or given value. So substitute here, find out 0.665 y3 dash. All of you very familiar from the derivation of DAB to DBA. So this is show that DAB is equal to DBA. For that case, so similarly we will consider here D21P is equal to D12P. So you refer my previous lecture. Derivation DAB is equal to DBA. So from that only we come to know D21P is equal to D12P. So that is equal to 1.874 meter square Pascal per second. Are you clear? Okay. So in this case also D2m into P is equal to 1 divided by. So here y1 dash divided by. So in this case D21 plus y3 dash we have divided by D23. So take all the values, find out the answer 1.847 meter square Pascal per second. So we want D2m. What do you do here? Divided with the pressure value here. So here divided with the pressure. So finally we get D2m value 1.539 into 10 to the power minus 5 meter square per second. Are you clear? By similar calculation, diffusivity of nitrogen in the mixture can be calculated and is found to be D3m is equal to 1.588 into 10 to the power minus 5 meter square per second. So how will you get D3m is equal to 1.588 into 10 to the power minus 5 meter square per second? So which one is the third component? Nitrogen. So nitrogen third component. D3m is equal to 1 divided by y1 dash divided by D31 plus y2 dash divided by D32. Are you clear now? Yes. So y1 dash is equal to what is that? y1 divided by y1 plus y2. Why? Third component is the free basis. y2 dash is equal to y2 divided by y1 plus y2. Are you clear? Now all the mole fraction values are known. Substitute mole fraction value, find out y1 dash and y2 dash value. Are you clear now? Yes. So now we know the concept DAB is equal to DBA, D31P is equal to D13P is equal to 1.945 meter square Pascal per second. Are you clear? Yes. So from that case D3MP is equal to the calculated value. Are you clear? From that we want D3m divided with the pressure. Finally we get 1.588 into 10 to the power minus 5 meter square per second. Thank you for your attention.